Okay, everyone. So now that we established that e is such a number that when you have a to the power of h minus 1 over h, and that limit is equal to 1, this base has to be e. Now let's rearrange this to isolate for e. Okay, so I'm going to first multiply both sides by h, but because it's a variable that depends on as h approaches 0, I have to bring the limit over to the other side. Now let's bring the 1 over. Okay. And then to isolate for h, I'm going to raise both sides by power of 1 over h. So e to the power of 1 of e to the power of h to the power of 1 over h. I'm going to write 1 plus h to the power of 1 over h. So this is another form of e. So 1 plus h to the power of 1 over h is going to equal to e. Okay. Another variation that we're going to be using very often is the following. Let's let x equal to 1 over h, and as h approaches to 0, right, x will have to approach, let's say 0 from the right side. Okay, it'll have to approach infinity. Okay, so we can change the h to x, but x will have to approach infinity, and we have 1 plus 1 over x to the power of x. This will also equal to e. Okay. So notice that I made h approach to 0 here. What if, if h approaches to 0 from the left side, we have x approaching minus infinity. So we could also do this as well. X approaching minus infinity. Okay, so that would also have to equal to e as well. Okay, so now we're going to use these three conditions to find some limits involving e. Okay, so for example, limit h approaches to 0. Okay, so let's say we have 1 plus 2h to the power of h. What is this limit? Okay, so we saw that if it was h and 1 over h, actually I meant 1 over h here. How would that change the limit? So if it was h and 1 over h, it would be e, but it's 2h. The important part is both this term here and this denominator is approaching 0 at the same rate. So if this is approaching at the rate of 2h, this also has to approach at 2h. Okay, so we can do that. We can multiply the bottom by 2, but also multiply top by 2. But I'm going to write the top by 2 as this, like that. So if I actually multiply it, that's the same thing as 1 over h. Now, this term, the second term, and this, okay, they're both approaching 0 at the same rate. So now we can say what's in here is e. Okay, so the limit is not e, but e squared. Okay, e squared. Let's do one more. Let's change it to 1 plus 3h, and let's change this into 1 over 2h. Okay, so I changed both of them. So what happens here? How can we accommodate this one? So 1 plus 3h. I really want this to be 3h. So let's think of this as 1 over h times by half. So I want this to be 3, right? Okay. So I can't just, of course, divide by 3. I have to multiply by 3 as well. So let's multiply by 3 here. And this exponent, I can bring it outside. Okay, using the exponent property. So we have 1 plus 3h to the power of 1 over 3h, all to the power of 3 over 2. So this here will equal to e, so we get e to the power of 3 over 2. Okay. So let's do a different one. Let's do an infinity one. So infinity ones, we saw that the property is like this one. Okay, so now we have 1, let's see, 1 over, let's say 3h to the power of h. Okay, note that's different. It's approaching infinity, and I have 1 over 3h. So once again, the rate at which this and this is approaching infinity has to equal. So this is 3, so we need a 3 here. Okay, but of course we can't just do that. We have to multiply and divide at the same time. Okay, now this is approaching infinity and this is approaching infinity at the same rate. So it's going to be e to the power of 1 over 3. Okay, last example. Change to x approaches to infinity. Let's say we have 2 plus 1 over h to the power of 2h. Okay. Here I change the 1 to 2. So how do we deal with that? We actually need to factor out that 2. Okay. When you do, okay, you get this. Okay, so this is h, so I meant this to be h. Okay, so what will happen here? So I get 2 to the power of 2h, right? When I expand, times by 1 plus 1 over 2h to the power of 2h. So this right here is clearly, when you take the limit, it's going to be e. But that, we have 2 to the power of infinity, so it's essentially really large number times by e, so it's going to be undefinedly large, infinity.